Often, we will want to know the pH of a solution so that we can know how alkaline or acidic it is. Before we had sophisticated electronic instruments to measure pH, there were various methods, one of the most common of which were indicators. And indicators are substances that turn a certain color at a certain range of pH. One of the best known indicators is phenolphthalein, which is pink in a base and clear at neutral and acidic pH. Phenol red is another common indicator that is yellow in an acid, orange at neutral, and red in a base. There are multiple indicators, and sometimes some of these indicators can be infused in paper strips, and then you can have little paper strips on a larger strip, each of which is sensitive in a certain pH range. And this is a type of pH indicator paper that allows you to note the pH of a substance across a broad range of pHs. Both indicators and pH strips allow us easily to measure the pH of common household chemicals. Let's start with distilled water. Here I have some commercially available distilled water and I'm measuring the pH. We would expect the pH to be neutral, but it looks here that either we have a very acidic batch of distilled water, somewhere between 4 and 5, or perhaps our indicator strips aren't working well. It looks like we might want to check these results. So let's get an indicator solution. Here we have our phenol red, and it's typically red in a base and yellow in an acid, and let's see what happens. We pour some in, and we wait, and swirl it around a little bit, and it's yellow. Indeed, it looks like our distilled water is indeed acidic. Now let's look at some commercially available alkaline water. So we put our test strip in and we look at the results and we wait a second. And it looks as though indeed our strips are still indicating an acidic solution. Maybe we have a problem with the strips. Or maybe the product isn't as advertised. Let's check. Here we have our phenol red. We put it in and we swirl it around and indeed it turns red, which indicates that we do have the presence of a basic solution. So now let's look at carbonated soda. Here we would expect the presence of carbonic acid, so we would expect it to be at least slightly acidic, and when we check the pH, it appears that this indicator strip is showing about a pH of 5. Next, look at some well water. This comes straight out of the well at my house, and so now we're looking, and it shows a pH of between 5 and 6. So it's probably 5.5. Next, let's look at some human saliva, which should be between the pH ranges of 6.2 and 7.6. So we put our strip in and we look at it. It looks fairly neutral. If anything, it's slightly on the acidic side, probably a little bit above 6. Now let's look at a common household acid, vinegar. And immediately when we dip the strip, we see that it changes color pretty quickly. And when we compare it to our scale, we see it's probably the pH between 2 and 3. So now let's look at a common household base, ammonia. And we dip the strip in here and we can see that it's quite alkaline, somewhere between 10 and 11. Now we can look at some other common household items, like baking soda. We know baking soda should be basic because it has sodium bicarbonate in it. So when we look at it, we see that it's probably around a pH of 8, between 8 and 9. Next up, some dish soap. Put our pH strip in, and we wait a few seconds, stir it up a little bit, and when we compare it, we see that it's not basic. If anything, it's a little bit acidic, somewhere between 5 and 6. Next up, some contact lens solution, which we would expect to be fairly close to neutral because anything that would be too alkaline or too acidic would irritate the eyes. And sure enough, it falls right around that range of neutrality.